This is Shweta Saxena. I welcome you all on this channel GK Tech. Today I would like to introduce data structure and algorithm. Friends, data structures are the collection of data items given a common name. See how. Collection of data items given a common name. Okay. Suppose we have 5 data elements. 3, 4, 5. If we arrange these 5 elements in contiguous memory allocation, for example, these 5 items are stored in form of contiguous memory allocation, means one is stored on first memory address, 2 is stored on second memory address, 3 is stored on third memory address, 4 is stored on fourth memory address, and so on. Okay. Then this data structure is known as array. If we arrange these 5 items in form of a list, and together with the item we store the address of next element using the pointers, then this data structure becomes linked list. See how? 1. Along with this data item, we also want to store the address of second element of the list. That is 2. Okay, this arrow points to the next element, and it is called pointer. Okay. Along with 2, we store the address of third element. Along with 3, we store the address of fourth element, and so on. At last, we don't have another element into the list, so instead of storing the address of next element, we store none. Okay, so these 5 items becomes linked list. Okay, if we store these 5 elements in form of a hierarchy or in form of a tree, when we say tree, then tree must contain a root node, child node. Okay. For example, first element, this is the address of left children. This is called root. Initial node is called root, and the left pointer points to the next element, that is 2. Okay. Right pointer points to another element of the list, that is 3. Okay. 2 contain again 2 addresses, left pointer and right pointer. It points to 3 and 4. And next element may be 5. One, 2, 3, 4, 5. Okay. There are only 5 elements in the list we have assumed. So, no element is present on right side. So, it stores null. It stores null, null, null and null. The first node is called the root node of the tree. These nodes are called the intermediate nodes. Okay. And the nodes having null addresses on left and right side are called leaves. So this type of structure becomes tree. Suppose we would like to form a cycle within the elements of tree. For example, this node points to this, and again this node points to, instead of null, this node points to this element. Okay. Then this data structure becomes graph because cycle is formed. This and this. Okay. So this is called graph data structure. Okay. There are some more data structures like stack and queue, but stack and queue will be implemented with help of array or linked list. Okay. So data structures are the collection of data items given a common name. If we talk about data structures, then we must have to define some operations, basic operations that can be performed on these data structures. See, what are the different types of operations? Okay. First operation is insert operation, delete operation, traverse operation, search operation, sort operation, and merge operation. These 6 operations are common to all the data structures. Okay. Insert operation means adding a new element to the list. For example, I would like to add 7 into the list. So, where I can add as first element, I can add the 7 as last element, or I can insert 7 in between the list. So, adding a new element into the list is called insert operation, and it can be applied to all the data structures. Okay. Now delete operation is what? Removing an existing element, say 4. Removing an existing element from the list is called delete operation. Okay. Now traverse operation. Traverse operation is what? Accessing each element of the list exactly once so that certain items in the list can be processed. For example, I would like to traverse this array and would like to print the element of array. So, I will go to the first element and print 1. Then I would like to access second element, I would print 2. Then I would like to print 3. Then 4, then 5. Now, I accessed all the elements of the array. I cannot access an element again. For example, I cannot access 4 again. It is not permitted in traversing. So, what is traversing? Traversing is accessing each element exactly once so that certain items in the list can be processed. Okay. Search operation. Search operation is simple. Searching an element in the list given a key value. For example, I would like to search 5 into the list. So, I will go to the first element, first memory address. I don't found 5. So, I will move on. Then I access second element. Then again I don't found 5. Then I access third element. I don't found 5 here. Then I access next element. This is 4. Again 5 is not found. Here I will find the element which I would like to search. So I will give the location of this array. That, for example, if array is named as A, then A0, A1, A2, A3 and A4. So, at the location A4, that is array with index 4. Okay, array having the index 4. I found the element. So, this is called a search operation. Searching an element given a key value. Okay. Sort operation. Sort operation is arranging the items in some logical order. It can be ascending or descending. For example, if we have got a list like this, 2, 3, 0, 1. I would like to sort this element. I would like to arrange this element into ascending or descending order, then this is called the sorting operation. Ascending order 0, 1, 2, 3 and descending order is 3, 2, 1, 0. This is called sort operation. Merge. Merge means combining two different lists into single one. Combining two different collection of items into a single collection of items. For example, I am explaining merge operation. We have 2 and 3 as an array of 2 elements and say 0 and 4. This is another array. So in merging, we would like to combine these two collection of items into single one. 0, 2, 3 and 4. This is called merge operation. I merge these two collections and form a single one. Okay. So this is all about the operations of data structures. Now I would like to explain some definitions of data structures provided in the book. Data structures are the ways in which data is organized in the memory of computer. We have seen different types of data structures. Array is organized in memory as contiguous memory allocation. Linked list is organized in memory with help of pointers or link. Tree is organized as hierarchical data structures. So we can say that data structures are the ways in which data is organized in computer's memory. A mathematical or logical model of a particular organization of data is called data structure. Data structure consists of two words, data and structure. Structure means organization into the memory. So, if we talk about the mathematical model of data structure, then we have to define how the data elements are stored or organized into the memory and what are the different operations performed on that data structure. So, it defines the mathematical model. These are the operations which are common to all the data structures. Okay. Next, a data structure is a collection of data elements. We have already seen that data structure is collection of data elements organized in a specified manner. Each and every data structure is organized in a specific way in the memory. Okay, that we have also seen. And accessing functions are defined to store and derive individual data element. What are these accessing functions? See, these are the operations which can be performed on data structures. Analogous to these operations, for performing these operations in programming language, you need to write functions. See, you need to write a function in C or C++ to insert an element into the array. You need to write a function in C++ to traverse the array. You need to write a function to search the element of array, to sort the element of array, or to merge the elements of the array. Okay. For inserting and deleting, we don't write functions because array is some information about the array is already known to the compiler. We can just read the array and write into the array. Okay, we don't need to define the functions for reading and writing into the array. For rest of the operations, we have to define functions. But for all the other data structures, we need to write functions to perform all these operations on the data structures. Okay, so these are written in form of accessing functions. Accessing function is defined to store and derive individual data elements. Okay. Third definition is the possible way in which data items are logically related defines the various types of data structures. We have already seen that how the elements of array are logically related, how the elements of linked list are logically related, how the elements of tree are logically related. So, it defines various types of data structures. Okay. I think it will be clear to you. Okay. So, this is all about the introduction of data structures. Now, in this subject, we would like to cover following data structures. We'll cover array into this subject, then linked list, stack, queue, tree and graph. In this subject, we'll cover array in detail. Okay. What are the different operations that can be performed on array? We would like algorithm for each and every operation. So, I would like to define algorithm here also. Algorithm is sequence of steps to perform the operation. We'll write algorithm, that are sequence of steps to perform the operation, in a pseudo code. Okay, algorithm is always written on pseudo code. Okay, this algorithm can be translated into C or C++ or Java or in any other programming language. Okay. So we'll just write the algorithm and we'll discuss in detail what is the space complexity of the algorithm, what is the time complexity of algorithm, how it is calculated, and okay. So in this subject we will cover each and every data structure in detail, its algorithm to perform all these operations into its algorithm to perform all these operations, and we'll discuss time complexity and space complexity. Okay, so this is just the overview of the content which will be covered in next lectures. Okay, thank you.